So good morning again, everybody. Welcome back. It is our second part of our lesson on adding and subtracting rational expressions. We're going to skip example 1 and just jump to example 2, which is strictly looking at how to add these expressions and stating the restrictions and everything. And again, the rules are really as follows. We want to have equivalent denominators, especially when we add or subtract. The goal is to find the lowest common multiple and then simply add and subtract the numerators. So again, pause the video whenever you have to, if you need a break or to look over. And here are the answers or the solutions for this question. The first rule again, and I'll write this over here, we're always supposed to factor. Right? And then we state restrictions, and then simplify. So for the first example 2a, we factored, done. There's nothing to do. So, second one, state restrictions. Looking at that 3 and a 7, done. There's no restrictions, so that's kind of silly. So then all we have to do now is simplify. But how do we do that? We have to get an equivalent denominator. So usually when I teach this to my students, and this one's really easy. In this example, the lowest common multiple, it's the product of the two denominators. The product of 3 and 7. Now what does that really mean? We multiply those together, and that is 21. That is the lowest common multiple. There are others, but this is the smallest one that's going to make it easier to do or to work with. Now I think some of you know what I'm going to do next. This is really me teaching it to you. Some of you can do this in your head. In order to change this 3 into a 21, I have to multiply this by 7. But whatever you do to one side or one part of the fraction, you must do to the numerator. In essence, I am actually multiplying this 2x over 3 by 1. Notice again, in order to change this 7 to this lowest common multiple of 21, I think a lot of you know, I need to multiply by 3. But again, in orange, if you can see this the YouTube video or in class, that's the idea of what you're going to be doing. And what we're going to do next, 3 times 7 is 21, 7 times 3 is 21. Notice the denominator is now the same. And so now we execute this step. 7 times 2x, that's 14x. That's the plus sign. And then 5x times 3, that's 15x. Before we continue with the final answer, everyone okay? This one is unfortunately super easy. But it's a reminder that it's not actually always going to be the product of the two denominators. And so simply now you simplify by adding or subtracting numerators. 14x plus 15x, 29x over 21. So some are saying this is pretty easy. And unfortunately, you have to be careful with adding and subtracting because there's actually an extra golden rule when dealing with this. Sometimes we simplify further. Now in this example, question A, there was nothing to continue. Any questions from the class on example 2A? Any questions? Cool. So let's come to question B then of the example. We got 3 over 2x plus 7 over 5x. Factor first. I'm done. Step 2, state restriction. There are actually 2 restrictions. I don't mean to insult you. Can I get a volunteer from the class? Please tell me the one restriction. David? 0. Nicely done. X cannot be 0. Everyone okay? If x was ever 0, we would have a problem. We don't like dividing by 0. Right? Everyone okay? Step 3, simplify. Here is the challenge question for everybody. And it's okay to make mistakes. Don't feel bad. I've already recorded this lesson in the other class, but this is for you. Can someone please tell me? Again, you don't have to do this. I find it helpful just to guide us what we're looking at. Sorry about that. Can someone please tell me what's the lowest common multiple between the 2x and the 5x? Arshia? 10 is close. I usually get that. It's not 10. Damien? 10x. 10x. Now, just to share with you, the third possibility, for some reason, if you were paying attention, ladies and gentlemen, some students say, what are you talking about, Mr. Chen? Isn't it just 10x squared? The way that we tend to talk about this lowest common multiple, and that's why I'm going so slowly, I'm looking at that 2x, I'm looking at 5x, and you're basically saying what's missing. So this, in order to get, we're trying to get 10, which is, again, a good answer, because that's what we kind of did here. So this is missing a 5, right? But it has an x here. Oh, and there's an x here, so it's only missing a 5. That's all it's missing. This one's missing a 2. Because both of them actually have x's there. So that's how you get this 10x. That's how some students do. Now, it might make more sense when we get to a harder question. These ones, for some reason, example 2, they're a little too easy. Right? So they don't reinforce this idea of the lowest common multiple. But I'm glad that our classmate didn't say 10x squared, because it's not always the product. It'll make more sense when we get through it. So now that we have the lowest common multiple, notice what we're going to do is execute that answer. So we got 10x in the denominator, and we have 15 plus 14. And so then now we just simply add those up. I think it's 29 or 10x. Just a small disclaimer. Please don't copy this down, ladies and gentlemen. If you decided to do 5x over 5x and 2x over 2x, it would not be wrong. It's just, you're just being very efficient. You would actually get then 15x plus 14x over 10x squared, and then add those two together, 29x over 10x squared, and then realize, oh wait, I have to divide up to reduce that. So get rid of that. So what's the big deal? Why can't I do it this way? We don't like it this way to go, we try and make you efficient. And so to recognize the lowest common multiple, it's easier. It's easier. That's why example 1, if you look at example 1 in the package, and if you're at home looking at your package that's online, example 1, it's a little confusing because you're trying to ask for equivalent fractions, that it might confuse you when we get to this part. Okay, so any question about example B? Notice they're very, very similar, but this one was actually to reinforce it's not always going to be the product of the two. Now question C, it's very, very similar. This one time I'm going to actually do this one if that's okay. In this case, this one is not really challenging. You factor first, everything's factored. State restrictions, there's no restrictions. Lowest common multiple, I think everyone agrees. We can definitely use higher numbers, but the lowest common multiple is 12. Let me just check to see this is on the screen. It is, it might be faded out, it's a little too small. So again, if you're at home watching this, you might want to pinch, maybe I should move this just a tad. I apologize if you're watching at home and you're getting a little dizzy. Whoopsie. I'm not a YouTube star. So the idea for this one, and again, a lot of you, I think, know what I'm doing if you're in class. Some students actually go this slowly just to be careful. 3 times that 2x minus 3 plus, that's this plus sign, 4 times 6x minus 1. Notice, this question is a little bit more challenging than the previous two. Right? So I think a lot of you know what you have to do now. We have to simplify, but not just any simplification. We can't just add these up together. A lot of you remember, we probably have to expand. Expand. In this case, watch what happens. When you use distributive property, we get 6x minus 9 plus 24x minus 4 over 12. Someone just double check from the class. Did I expand that correctly? Just double check. Thank you, Tyler. Then we have to collect like terms. 6x and 24x, that's 30x. Negative 9 minus 4 is negative 13 over 12. And that is our simplified answer with no restrictions. However, I want to take this as a moment, as a teaching step, just to explain this yellow instruction. In this example, there was nothing to worry about. We got 30x minus 13 over 12. Ladies and gentlemen, in the class, let's pretend, and again, maybe I think I can see it. Let's pretend this was the answer. Again, I encourage you, if you're in class right now, to copy this out. Let's pretend that this is the answer. This is not the answer, but let's say we got 30x minus 12 over 12. Let's just say we had this as the answer. Again, this is not the answer, we got negative 13. We got this one. 30x minus 12 all over 12. Anyone see anything maybe what we can do further? Anybody from the class? Damien.
Divide up the 12.
Divide up the 12. In fact, what I would recommend before you divide up the 12s is maybe factor. Not always, sometimes you have to do exactly what our classroom said, maybe just divide out the numbers. But in this case, it's probably a little easier just to share with you your skill set of simplifying further by factor. So what's the number that goes in this one? Well, I think everyone agrees it's 6. 5x minus 2 over 12. I'm not saying our classmate's incorrect. Maybe some of you realize they're all even, right? Or maybe 6 goes in all 3 of these coefficients. This tends just to be, in my opinion, just the easier way to think of it. Once you factor, notice 6 goes into 6 once, 6 goes into 12 twice, and this is our final, again, our answer for this question. Let's just pause for a second and talk about this. That is why adding and subtraction is so devious. It's because when you collect the like terms, initially, we don't know if we have to go further. Okay, so again, I changed our answer when we did this question to get this 30x minus 12 over 12. I just changed that negative 13 to a negative 12. And I'm just trying to show you that sometimes we have to go a bit further. And that's what you have to kind of pay attention to. Are there any questions from the class? I'll leave that on the chalkboard still. Hopefully it got onto the recording. I think it did, yep. And hopefully it is recording. Yeah, talking already for 11 minutes and 50 seconds. I'm going to now take a look at example D. Still leave this information there. Question D is, unfortunately, I hate. So if you get confused, ladies and gentlemen, don't panic. Let's make sure. Any questions still from the class? Any questions at all? So question D is 4 over 3 minus x plus 3 over x minus 3. See, now let me do addition. So the rules in blue that you see in the chalkboard, it says factor first. We are done. Stating restrictions. I think everyone agrees x cannot equal to 3. Simplify. Now something should be suspicious. A lot of you realize this is sus. This 3 minus x and this x minus, they look interesting. Is the lowest common multiple the product of the two? Why not, Mr. Chen? We could do it that way, we could. But I am trying to share you that maybe with these two questions, maybe we actually didn't do the factoring properly. Don't get me wrong, that's the right restriction, right? If x is 3, that would go to 0, that would go to 3. So what are you talking about, Chen? But that's why, one more time, and we'll do this hopefully in green chalk, hopefully you guys can see this. This 3 minus x, we actually can factor. Now, the reason why I use this one rather than this one is because most students are more comfortable with this style, seeing the variable first, and then the constant term second. Variables first, then the constant term second. This one's the other way around. This is the constant first, and then the variable second. It's a little different. So in this example, 3 minus x, technically, if we take out a GCF of negative 1, watch what we're going to get. We're going to get negative 3 plus x. One more time, subtraction is not commutative, meaning 5 minus 7 is not the same thing as 7 minus 5. But addition is commutative, meaning 3 plus 1 is the same thing as 1 plus 3. So even though with this subtraction understanding, Mr. Chen, these look the same, what are you talking about? Can't I just switch them? The answer is no. Technically, we factor out a negative 1, we get negative 3 plus what x, and I think a lot of you know what I'm doing. If you check my expanding, you get the top line. But with this now changed to addition, I can swap this. I can put this one first, which is the x, and put this one second. And ladies and gentlemen, technically, and just, I'm running out of room, so hopefully this is okay. I'm gonna just do it like this. And a lot of students realize that Mr. Chen does not like negatives in the denominator. So hopefully it's okay that I put the negative up here. So hopefully I didn't go too fast. Any questions there? It's okay, I don't mind repeating it That is why question D, a lot of students, it seems easy. It seems so, what are you talking about? It's nefariously making to you to kind of think of this, and that's in my opinion, is the best way to kind of deal with this. And so you should be suspicious about that. And to build up your repertoire that sometimes factoring out a GCF of -1 might make your life a lot easier. In this case, the lowest common multiple, well, it's the same. You didn't have to do anything. The lowest common multiple is x minus 3. I don't have to do anything. So that's why I was trying to share with you. Minus 4 plus 3, -1 plus 3. And that is the answer for this question. One more time, I think a lot of you know what I'm doing here. I like my negatives in the numerator, so like -1/2. It's the same or equivalent to 1/-2, which is the same as a negative fraction. And that's what I did here. That's okay if I went slow enough with the green. Okay. Any questions from the classmates? And we're to the last example before I pause the video and everything. We're at question E. Oh, this one is your first glimpse of subtraction. And that's why I think it's a little better in class than it is learning this at home, because then hopefully you get some time to absorb this. In this case, we do the same 3 rules in blue. Factor first, state restrictions, simplify. Factor, done. Restrictions, there are no restrictions. Simplify, lowest common multiple. It's 15. Just to show my work as a teaching tool, I need to multiply this by 3 and 3, and multiply this by 5 and 5. Any questions so far, so good? And you know, as my students, ladies and gentlemen, you don't have to ever show this to me, but it should be in the back of your head, and this might assist you, especially when we get to harder questions. So take our time. 3 times 5x minus 2. I think everyone's okay so far with that. Watch what I'm doing, ladies and gentlemen, in the class. I'm going to copy the subtraction symbol, but I'm going to use a different color. When you see subtraction, you need to be very careful. In grade 9, when you were dealing with linear equations, and they were binomials with a subtraction symbol, many students in grade 9 made this mistake. It's not that you don't understand how to do this part, 5 times, what are you talking about? 5 times 2 equals 7, that's correct. But when you multiply this by 5, eventually you want to subtract it. So I recommend immediately after you subtract, you put square brackets. Sometimes it doesn't matter. In fact, some of you realize you are going to get negative 10x. A lot of you get that. It makes sense because this subtraction sign is in front of it. But I must show you kind of a technique that I think it'll make you a bit more careful when subtracting these kinds of questions. And the reason why is many of you understand this is positive 35, but you will still copy out positive 35. You will have forgotten that you're subtracting this whole thing from this portion of the question. So one more time, watch what I'm going to do. 3 times 5x is 15x minus 6. This is never usually the wrong or difficult part. I'm going to just do this. 5 times 2x is 10x. What are you talking about, Mr. Chen? 5 times 7 is 35. But when you clear these brackets of the subtractions, notice what happens. That becomes negative. And many students, any of the remaining part of the question, usually get this one wrong. Even though the 35 is correct, the positive 35 is correct, when you subtract from something, notice it becomes negative. And I apologize, this is bad math. Normally I write underneath, but it's because we're doing this. 15x minus 10x, I think that's 5x minus 41 over 15. And I think that's the answer. There's nothing else to reduce, although 5 and 15. 41, I think, is a prime number. So one more time, the reason why this question is there is to introduce that subtraction, you have to be very careful. One more time, please don't copy this down if you're in class. But most students do get this 15x minus 6 over 15. They get the minus 10x, but then they forget and they put the positive 35. And then they're going to get this wrong. Everyone see what I'm trying to show you? This is the whole point of what we're supposed to look at in grade 9. Which, again, don't get me wrong, it was 2 years ago. And some of you have forgotten that. And that's okay.